Welcome. In this video, we are going to take a look at problem 10 from chapter 20 of College Physics 2E by OpenStax. We have a clock battery. We know it wears out after moving 10,000 coulombs of charge, and it moves that charge at a rate of 0.500 milliamps. We need to figure out how long the clock ran and how many electrons per second flowed. Let's start with what we know. Okay, the Q, the amount of charge, and now we're dealing with electrons. So when they tell us it's 10,000 coulombs, that means it's an absolute value. So let's do absolute value of delta Q is 10,000 coulombs. Okay, that rate is in milliamps, so that's our current. Current I is 0.500 milliamps. That will need to be converted to amps. In part A, we're looking for delta T. In part B, we're looking for the number of electrons per second. Let me just add per second. Okay. We can find delta T using the equation for current. I is the change in charge over the change in time. So that means if we multiply both sides by delta T, I delta T is equal to the change in charge. So now divide both sides by current I. Our delta T is the change in charge over the current. Okay, we have both of those numbers. So this is going to be 10,000 coulombs divided by 0.500 milliamps. And we need to convert this to amps because 1 amp is 1 coulomb per second. Otherwise, we'd have millicoulombs per second, which won't cancel our coulombs. So we convert that to 1 amp, and in 1 amp, there are 1,000 milliamps. Okay, this gives us 2.00 times 10 to the 7 seconds. So there's our delta T. Now in part B, we need the number of electrons per second. Let me just clean that up. And actually we can do NE over S. All right, so let's look at this. So I, we said, has units of amperes, and that is a coulomb per second. So if we take I times 1 electron, which is the Q sub E, unit-wise, we'll have coulombs per seconds times the number of electrons per coulomb, which indeed gives us our number of electrons per second. Okay, so the number of electrons per second is going to be the I, which is 0.500 milliamps. Again, we convert. 1 amp is 1,000 milliamps. And now we multiply this by 1 electron. And here we're using the absolute value again. And so we're getting 1.60 times 10 to the minus 19 coulombs. Okay, this gives us 3.125 times 10 to the 15 electrons per second. And so we can call this 3.13 times 10 to the 15 electrons per second. And that's our answer. Okay, I hope you found this helpful. Let me know in the comments section if you have any questions or there are other problems you'd like to see. Thank you for watching. Please like and subscribe, and I'll see you in the next one.